Hi class, we are now on chapter 3.9. This is energy, chemical and physical change. So we're going to look at the energy and the physical chemical changes here. Physical and chemical changes are accompanied by energy changes. So when you sweat, that's water molecules on your skin. The water molecules absorb energy and that helps cool you off. This is a physical change because the water will evaporate away from the skin. A chemical change is natural gas burned on a stove, The energy is released during the chemical change, and that will allow the heat to under the stove to heat up the food. I'm getting tongue-tied here. Let's take a look at this picture. We just covered in the prior section potential and kinetic energy. Well, one thing about chemistry overall you should understand is that chemistry will always try to be at its most stable, lowest energy state. It will always try to go that way. And this is a perfect example of that. You have a weight that's very high and that makes it extremely unstable. So it's got a very high amount of potential energy. It will try to, if it's able, to release that weight and go to a different position, a lower position, to release that high amount of potential energy, which will make it more stable. So a weight lifted off the ground has a high potential energy, and it will try, if it's able, to fall towards the ground to release some of that potential energy and make it more stable. So systems with high potential energy have a tendency to change, resulting in a low potential energy. This is why some compounds are very unstable. They are unstable because they have a high potential energy and they want to release that energy to become stable. So some chemical reactions with that, for instance, things that have to do with combustion, flammable bombs, these are very unstable compounds that need to release that energy, and when they do, they release that energy as heat. So here we have chemical changes. Some chemical changes, such as molecules that compose TNT, that's a bomb, have a relatively high potential energy. The energy is concentrated in them, and remember, potential energy has a lot of energy, but if it's too high, it will want to get rid of that so it can become more stable. And that's why it's so explosive and needs to be handled with care, because of the amount of energy it needs to release. Here's a diagram to show you what this means. So this is energy. As energy goes up and over time. If you start out with TNT as a reactant, this is a starting material. Then as it combusts or explodes, you will have new product material. And if you see the energy level is very low, that means that in the explosion, it has released a great amount of energy as heat, and now it is more stable after that explosion has occurred on these compounds. So this is not in your book, but this is good for me to explain the next slide. So I want you to understand what a system is. And as you get into more labs, things will always be referred to as systems. So a system is where the chemical reaction takes place. There's three types. There's an open system, which is open to mass and heat change. There's a closed system, which is open to heat change, but mass stays in the system. And then there's an isolated system where nothing's allowed in and nothing's allowed out. And depending on what type of system it is, that's how you will know, you will obtain different information in your experiments. So with that being said, we wanted to look at endothermic and exothermic reactions. So if you have a system that you're doing a reaction, you will notice either heat going in or leaving this, or being released from the system. Then you're dealing with endothermic and exothermic reactions. So an endothermic reaction is cooler than the surroundings. So the system is where you're doing the experiment, and everything that's not part of the system is called the surroundings. And if it's an endothermic reaction, what you will notice is that the heat from the surroundings will go into the system, making it colder. So what do I mean? Hold an ice cube in your hand, and the ice cube is very cold. What it's doing is your hand, it's pulling energy from your hand, and that energy is going into the ice cube. That's why your hand is cold. Exothermic, the heat is being released from the system into the surroundings. That's why if you sit by a fireplace, you will be warm soon. It's because the heat is going out into the surroundings away from the system. A cold spoon in hot chocolate, that spoon will get hot soon because the heat will flow into the cold area and warm up the spoon. So endothermic, when heat transferred from the surroundings to the system, the reaction absorbs heat from the surroundings. Exothermic is when heat is transferred from the system to the surroundings, reactions that transfer heat to the surroundings. Q, we haven't really covered Q yet, and we will soon. This will come back, so I suggest you make a note about Q in here, because we're going to cover Q later on. But right now, what I want you to focus on is just the plus and minus signs. So if it's an endothermic reaction, meaning heat goes from the system into, surroundings into a system, then it is a plus sign. It's like you're depositing money into an account. And if, heat is being lost from a system and it's going out into the surroundings to warm you, that's deductions from a bank account. It's negative. So that's a good way to remember that. Heat being released by the system is negative, and heat being added to the system is positive. So let's take a look at these as well. So an endothermic reaction, energy is exothermic reaction, energy is released. That's the heat that you're feeling. That means that the reactants had higher potential energy than the products, and it had to release that energy as heat in order to get to the stable products. Think of a TNT. It's very explosive, but once it explodes, then it becomes a stable product. Endothermic, as you see, the reactants are down here, and the products have a higher energy. So what it is that this needs energy. It has to pull energy from the surroundings in order for this reaction to occur. So it has to take energy in, which is why you see products as a higher energy. It's higher energy than the reactants. This is an endothermic. It pulls energy or heat out of the surrounding in order for this reaction to occur.